Bismillahirrahmanirrahim. Assalamu alaikum, dear student. I do hope you will be in best of your health. Previously, we have comprehensively studied uh, various methods for solving first order differential equation. Uh, in today's lecture, I will apprise you about higher order differential equations. Today is the introductory lecture about higher order differential equation. In the forthcoming lecture, we will study various methods for solving higher order differential equation. So let us start our today's lecture. Higher order differential equation. First of all, I will tell you about the initial value and boundary value problem. We may define an initial value problem for a general nth order differential equation. For a linear differential equation, an nth order initial value problem is a n of x dn nth derivative of y respect to x plus an minus 1 x n minus 1th derivative of y with respect to x plus so on and so forth a1 of x and first derivative of y with respect to x plus a naught of x y is equal to gx subject to y at point x naught is equal to y1, y prime at x naught is equal to y1 plus so on and so forth y nth n minus 1th derivative at point x naught is equal to yn minus 1. This is the nth form of initial value problem. What is initial value problem? If boundary conditions are given at one point, that problem is called initial value problem. I earlier told you that if we have nth order differential equation, then we will have nth boundary conditions. It can be for convenience if we have n is equal to, that is second order differential equation, a2 of x d2y divided by dx square plus a1 of x dy by dx is equal to a naught of x y is equal to 0. This is the second order differential equation. When we solve this differential equation, we will have two constant. So in order to find those two constant, we require two boundary conditions. So if these boundary conditions are at one point, this is called the initial value problem. Uh, I will clear the boundary value problem for second order differential equation. This is the second order differential equation. Uh, Now the boundary condition are given at 2 points. Y1 prime of 0 is equal to 1 and y1 is equal to 0. So I summarize again. If the boundary conditions that are given to find the value of the constant are given at one point, that is called the initial value problem. If the boundary conditions are given more than one point, at one more than one point, that is called boundary value problem. Previously, we have studied homogeneous differential equation or ordinary differential equation for first order. Now we will generalize this idea for another differential equation. Simply, if the differential equation is equal to 0, that is called homogeneous differential equation. In equation 6, the nth order differential equation is equal to 0. This is called the homogeneous differential equation. If this differential equation is not equal to 0, there is a function of x independent variable, that differential equation will be non-homogeneous. For convenience, if we have n is equal to 2, uh, a2 of x dy d2y over dxk plus a1 of x into dy by dx plus a naught of x y is equal to gx. This is the non-homogeneous equation. If we put g of x is equal to 0 in this differential equation, then we will have the homogeneous differential equation. Now we proceed toward the a question from the exercise 4.1. In problem 1 to 4, the given family of function is the general solution of the differential equation on the indicated interval. Find a member of the family that is a solution of the initial value problem. So the student in this question, differential question is given and its solution is given. As I told earlier, how we find the solution of higher order differential question, we will learn this method in our forthcoming lectures. But today we will analyze uh, the higher order differential question and its solution. Yeah, y is equal to c1 is c1 into e power x plus c2 e power minus x is the solution of differential equation which is given y double prime minus y is equal to 0, y of 0 is equal to 0, y prime of 0 is equal to 1. Solution is given and differential equation is given. We have to find the value of the involved constant c1 and c2. To find the value of C1 and C2, we will first use the condition y of 0 is equal to 0. It's mean that its y's value at x is equal to 0 is 0. We will put in equation number uh, 1. 1. So y of 0 is equal to 0 is equal to C1 plus C2. We will label it as equation number 2. As the second condition is a derivative, so we differentiate equation number 1 with respect to x, and we will use the condition y prime at x is equal to 0 is equal to 1 in equation number 1. We will have 1 is equal to c1 minus c2. Solving 2 and 3 uh, to find the value of c1 and c2, we will have c1 is equal to 1 by 2, and using we can to find the c1 value of c2, we can use the value of c1 in equation number 3 or 2. I have used in equation number 2. Using the value of c1 in equation number 2, we will have the value of c2 is equal to minus 1 by 2. Using the values of c1 and c2 in equation number 1, we will have the general solution. Y is equal to 1 by 2 e power x minus 1 by 2 e power minus x. Now we have a particular solution. This is earlier it was given solution as a in term of c1 and c2. C1 and c2 were unknown. Now c1 and c2 are known. This is the family of the initial member of the family, that is the solution of the initial value problem. Now let's proceed toward question number 4. A similar method will be adopted. Question number 4, y is equal to c1 plus c2 cos of x plus c3 sin of x. This is the solution of the third order differential equation which is given y triple prime plus y prime is equal to 0, and boundary condition at y pi x is equal to pi is equal to 0, y prime at pi is equal to 2, and y double prime pi is equal to minus 1. Using the first condition in equation number 1, we will have 0 is equal to c1 minus c2 plus 0. This is labeled as equation number 2. As the second condition is on the first derivative, so we will differentiate equation number 1 with respect to x, and we have y prime is equal to minus c2 sin of x plus c3 cos of x. Now, using the condition at first derivative y prime at x is equal to pi is equal to 2, put x is equal to pi and y prime is equal to 2, we have 2 is equal to minus c3, or c3 is equal to minus 2. As now the third condition, as the second derivative, we will differentiate first derivative. We may label it as equation number 3, and this is 4. So differentiate equation number 3 with respect to x. We have y double prime is equal to minus c2 cos of x plus minus c3 sin of x. Using the third condition, y double prime at x is equal to pi is equal to minus 1, we will get the value of c2 is equal to minus 1. And now we have determined the value of c3 and c2 using the value of c2 in equation number 2, so that we can find the value of c1. C1 is equal to minus 1. Using the value of c1, c2 and c3 in equation number 1, we have this solution. Y is equal to minus 1 minus cos of x minus 2 sine of x. Now, consider question.